So welcome to the session on backtracking. Backtracking is one of the advanced algorithms, right? It's one of the advanced algorithms techniques because there are multiple techniques for advanced algorithms. One is backtracking, one is dynamic programming, you have divide and conquer, you have greedy algorithms. There are a lot of algorithms for advanced algorithms, right? So the first one we will look at is backtracking here. So what is backtracking? Before we get into backtracking, one of the most important things is you need to have a good handle of strings, arrays, loops, right? These three concepts you should be really good, and then you should also know recursion. These are the important things before you get into backtracking. Now let's get into backtracking. So first problem we will look at is a simple night store problem, right? I'm not going to discuss the solution or anything. I'll tell you the concept of backtracking here. So this is one of the questions for which backtracking is really ideal. So when you look at it, first a night has to start here and night has to reach here. This is the problem statement that we have. So the night is going to start here and it jumps from here to here. All of you know the night moves in an L path, so it jumps here. Next it will jump from here to here. Next it will jump from here to the next point and then it reaches the destination, right? So there are 4 steps it is jumping to get to the destination. This is one problem that can be easily solved with backtracking. We will look at other problems as well that we can solve with backtracking. There are many more that can be solved. I'm just giving a few examples here. Once you look at these problems, then we will discuss the backtracking algorithm. You will have a handle of how it works. Let's move on. So this is another question that can be solved using backtracking. There is a list of words given here and there are list of words given here, right? This is a grid that has been arranged with a lot of letters. Now if you look at it, B-A-R-K, bark is here, park is I think P-A-R, sorry, I think, okay, park is not there, P-A-R-K probably, right? Park is there, and M-E-N, so you have M-E-N or M-E-N is there, lot is there, L-O-T, cement is there, I think C-E-M-E-N-T, right? So you have to find a particular word is present in the grid by moving down, right or across. If this is a question that is given to you, how do you solve it, right? This backtracking can help you solve this particular problem. Let's look at a few more examples here. So this is the solution matrix, right? For each of these questions where it is available, it's been given here. Let's move on. So let's first talk about this rat in a maze, which is one of the most popular questions for backtracking, right? So with this, we'll explain the concept of backtracking as well. So let's move ahead. So this is a maze that is given here. These are walls in the maze in which you cannot enter the walls. The white cells are the only cells where you can move. This is given as a starting point. This is given as the destination point, right? And what it has been given as a constraint is the rat can move only right and down. That means the rat can move down, right. Only 2 positions are allowed. It cannot go left. It cannot go up. These are the constraints given. So the rat can move from here to here, from here to here, from here to here, 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 here. It reaches the destination. But if at all it starts here and it goes in this direction, it will hit a dead end. There is no way to get to the final solution because it cannot jump from here to here. It will be stuck here. So this is a question that we will use to explain the concept of backtracking, how the concept works, right? Let's move on. So when you look at it, this is another question, right, which can be solved with backtracking. I think if you look at it, this is a chessboard available and there are 8 queens available on the chessboard. As you know, a queen can move in this direction on the diagonal. You have to place 8 queens so that they don't cross each other's path. That is another typical backtracking problem. So usually this is a very popular one that we solve with backtracking. Let's move on. So what is backtracking, right? So now we looked at the maze question, right? In that you saw that there was a maze and there was a dead end. You could not move in that direction. It resulted in a dead end in one path. Another path, it went to the solution. Take this analogy here. You're starting here, right? And there is a path to a success. But you're going another path, it hits a dead end. When it hits a dead end, you backtrack, you come to the previous question, you see if there is an alternate path from there, and if there is a path available, you proceed, otherwise you hit a dead end there. or you come back one more step, you move forward, you might hit a solution or a dead end, you come back. When you come back, that's called backtracking. You take a step forward, you backtrack, right? You backtrack, you move in another path and you hit a dead end again. Then you try a final attempt, right? There is another path, again it's a dead end, and then you reach a success. So backtracking is nothing but you go in a path, you see if there is a solution available. If there is no solution available, you come back one step, and from that step you try to proceed forward to see if there is a solution in an alternate path. If there is no solution in any of these paths, then you don't have a solution. But probably you tried all the paths and one of the paths you resulted in a solution, you hit the success. So the recursive algorithm automatically takes care of the backtracking part for you, which is what we'll see in this particular algorithm. So let's move on. What is backtracking? The definition of backtracking is, it is an algorithmic technique for solving problems. One, recursively by trying to find a solution, one piece at a time it moves forward. If there is no forward position available in that particular thing, you don't reach a goal. You come back, you remove that particular step and move an alternate path. This is what is meant by backtracking, right? Let's move ahead and we will look at a template for backtracking solution. This is very, very important for all of you to understand. This is a template. Register this template. We will revisit the same slide multiple times, right? I'll walk through multiple solutions, but you will see that the same template is being followed for all the questions that we are going to do with backtracking. It is the exact same thing. Some questions might need something, some questions might not need something, and eventually, right, after you solve 8 problems with backtracking, you will realize that when to apply which particular is pruning required. Do we have to do visit an already visited cell? Do I have to check for it? They have to check for invalid questions like that. Each of these, when to use which one is something you will understand once we solve all these problems. I will take this template as the base template. We will solve many problems with the same template and we'll come back and see how this template has to be applied for each of these problems, right? That's where it is. So let's take the first question, right? The first problem that we want to discuss is rat in a maze. So look at this particular question. So we have a maze given here, right? There is a maze given here. So we saw this slide already. There is a source, the rat is here, the rat has to reach here. These are walls it cannot pass through. These are the tiles where it can move ahead. So how does it find a path from this source to destination? So that's the question, right? How the input will be given as, all the walls will be given as 1, all the tiles which you can move will be given as 0. So it will be a 2-dimensional matrix that will be given 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. This is the matrix that will be given to you. The output for this particular question should look like 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1. That means wherever you have the path, all those cells will be marked as 1 when you finally display. So this is the input given, this is the output expected. You have to write a program which will solve this.